How's everybody doing? All right, Nick, I expected a little more. We'll try it again. How's everybody doing? All right, welcome to Android Summit. I am Joni, and I am here. I had asked Claire, actually. So I talked to Claire last night, and I asked her, because I knew she'd do a great job. And I was like, Claire, I need you to tank it. You were at the table, right? I need you to tank it right at the end to really set the stage for me. So if we set the bar really low, when people show up in here, then we can wow them. And she did not come through. So we're here to talk about Flutter and Firebase and the journey that we went through over the summer to build the app that hopefully you guys are using for the conference today. So with that being said, who has the app installed on their phone right now? That's amazing. Thank you. If you're not in that group, get it quick. Or you could be an iPhone user. How many iPhone users? So these people did not raise their hands when I asked who installed it for a reason, and I'll get into that in a minute, and I apologize. But if you're on an iPhone, trust me, the app is great. Apple just, I had some hurdles to get through that we weren't able to get accomplished by today, so I apologize. The website still works great, so you can go to the website from your phone and get all the information you need. If you have the app, as we talk through today, I encourage you to follow through as we do some of the discussion of the features that we implemented, and that'll make the experience a little better for today's talk. So with that being said, let's set some expectations. First off, my name is Joni. As I said, I'll introduce Basir and Bill here in just a minute, but I work at Capital One. I'm one of the Android team leads at Capital One, and I also am one of the organizers for DC Android and DC Kotlin. A quick plug, so right next to us, Britt is giving a talk in the other developer track. She's speaking at DC Android on Monday evening. So if you're missing her talk and that really bothers you, you can show up Monday evening at the DC Android meetup and hear her. So you get both. So you picked the right one. What are we going to talk about today? So I'm going to give you a little bit of background about the decisions that went into the app. So what we needed to have in it, why we chose some of the technologies that we chose. I'm going to overview some of those technologies very briefly. We'll go over some implementation details. I want to set expectations here because this will be more of a high-level talk about how and why we did things. The talk directly after this will really go deep on Flutter. So if you're interested in that and you want to stick around for that talk, and that should be great. We'll talk about some of the pitfalls that we encountered as we were developing over the summer, and then finally we'll give our final thoughts, our assessment on Flutter as a framework, Flutter and Firebase and how they work together, and then I'll hold my opinion about the interns to myself. They already know how I feel. So, all right, so just like any app, you've looked at it. The main feature of the app is the schedule. So if you're looking at it, the first thing you're going to see is the schedule. And this is what we mainly wanted. Just like any conference app, we want to schedule. We need the ability for speakers to show up and for their profiles to be readable, details about the given events, log in. I'll talk about this in just a second. One of my bosses was really serious about having Twitter integration. And I won't tell you who it is in the pink shirt over there, but so that was one of our requirements. We also wanted to abide by material design patterns because it's an Android Summit conference app, and we're Android developers, or at least I am. And finally, it needed to be cross-platform. So myself and another team lead, Sandeep Gadi, who's not here today, went through this and said, okay, that's great. And then we kept going. But wouldn't it be really great if that schedule was also filterable? And we have bookmarks. So if you go on the schedule right now, you see you can bookmark. And all of those bookmarks are now saved on the back end. And if you log in on a different device, you have the same bookmarks. Wouldn't it be cool if we could do that? And wouldn't it be cool if I changed the schedule, you get real-time updates. So you don't have to get a new version of the app. Everyone just automatically gets whatever changes I apply, and boom, you have it right there. And wouldn't it be really cool if you got notified for any announcements I want to send out? So hopefully, did you guys get announcements this morning about the keynote starting and all that stuff? All that happened on the back end. I'll explain it in just a minute. All these were like, wouldn't it be cool if we were able to do that in the app? And then we just kept going and said, also, we need to have the ability to do announcements. We want to do remote configuration because we want to be able to use this app in the future, and we don't want it to be all hard-coded into the app. Michael Jones wanted us to integrate Google Photos, so in the app you can actually open the side menu bar, click on where it says, I think it says Google Photos or something like that, and it opens up the shared Google Photos album, so you guys can take pictures, put them in there, everybody sees them. It's pretty awesome. Importantly, there's also a link on that menu for donations, so we know we're supporting Women Who Code. So if you click on the menu item that says donate to Women Who Code, it goes straight to their site. You can donate right there. And finally, our last requirement was networks are not that great, especially when we're on hotel Wi-Fi. We have 3 billion people trying to access the same access point. It's going to go down. So we need the ability to cache this data locally so that when you lose that network connection, you don't lose everything in the app. It's not just a blank screen staring at you. Sounds good, right? One caveat, we got to get this done in 10 weeks. How are we going to do that? So we made some decisions based on this. What technologies exist that would enable us to do this rapidly, still provide a polished solution to the users of the app, not crash, and be cross-platform? There's lots of cross-platform solutions out there. Who's done a cross-platform app before using a different cross-platform? So a few folks, right? So we have Ionic, we have React Native from Facebook, Microsoft has Xamarin, lots of different options. We chose Flutter for a few different reasons. The biggest one being Google's really been hyping it up, and as an Android developer, I'm kind of a Google fanboy. So I had to try it out to see if it was worth the hype, and I'll tell you at the end whether I think it was or not. But we went with Flutter, and Flutter does the cross-platform thing a little differently than many of the other cross-platform solutions. So I just want to do a brief overview of how Flutter handles cross-platform. And so when you write the code, who's written a Flutter app, by the way? Anyone in the room? So we got half a dozen or so. Okay, good. So for everyone else, this may or may not be new to you, but when you write an app in Flutter, you're going to write it in Dart as a programming language. Dart 2 now is the version that's out, but Dart is the language you're going to write in. And for us, this was one of the considerations when we started looking at timelines. Do we have enough time to learn a whole new programming language and also build an app? So that was a concern going in. We went with it anyway, and I'll talk about that in a few minutes. Flutter also doesn't use native components like some of the other cross-platform solutions. So what it does is Flutter has an engine written in C and C++ that runs natively on your device. When you compile your Flutter app, it's compiled using the Android NDK or the iOS LLVM into native code. And then when you write your code in Dart, it's compiled ahead of time into an ARM library. And when you run the app on your device, Android or iOS, what happens is the Flutter engine runs your Dart code on Skia, which is a 2D graphics library, or 2D graphics engine, excuse me, and renders it all on the screen. And it looks like native components. If you're on Android, you can make it look like native Android components. If you're on iPhone, it looks like native iPhone components. But all of those things are being rendered actually on the Flutter engine, so they're not really native components. And when the guys come up, they'll tell you about that here in a minute. So what does this do for us? So at the end of the day, and this may sound familiar to you, it's very much how games work, right? The games on phones run on an engine, and they build all of the graphics on top of that. That's how Flutter works, which makes it very performant. They advertise that it's easy to achieve a constant 60 frames per second. And in our experience, that seems true. I didn't actually test to see what the frames per second was, but it's pretty smooth when you're scrolling and stuff. Hopefully you've had that same experience. All right. On the back end, we chose Firebase. We chose Firebase because it provided out of the box everything we needed. All those things that I said were requirements that required back-end servers to be able to do those things, Firebase provided. So it's multi-platform out of the box. It provided us authentication. So in the app, you can sign in with your Google account, which is great because then it persists your bookmarks and everything across devices or across sessions if you log in and out. Or you can sign in anonymously. It provides a database, which we use. We use the RealTime database, which you'll hear about in just a minute. And what that does is provides us the ability to give real-time updates. This is how we're able to push changes to the schedule, to the events, notifications. All these things are through the Firebase database. Push notifications, so Firebase Cloud Messaging is built right in, and it works great. That's how you got the notifications earlier about the keynote starting. And lastly, remote config. So you can completely configure your app remotely and change the entire user experience just by changing some key value pairs in Firebase, which is pretty amazing. Has anyone here used Firebase? Okay, a lot of people. So Firebase has been around for a while. It's a pretty mature product. Google bought it out and added a ton more to it. We didn't use nearly as many features that we could have used, but what this did was free us up from having to build all of the back-end stuff. Because remember I said we only have 10 weeks? And the one thing I haven't talked about yet is we had requirements. We determined what we were going to use to build out the client apps. We determined what our back-end was going to be. What we didn't figure out was who's going to write all this. I have a day job, right? I have a team. They're all sitting at that table right there. Say hi, Team Panda. Hey. They're not going to write it because I want them to write other stuff. So who's going to write this code? Surely not just me. Luckily, Capital One has an internship program. And so these guys, Basir and Bill. So I was really lucky to get a couple guys, computer science students at the University of Maryland and Georgia Tech, respectively, join us for the summer. They were here for 10 weeks. I had them for about 7 or 8 after you take away other internship things that happen. But for the most part, they joined us. I had them working on this app all summer. They're going to tell you all about it. So without further ado, the interns.
Yeah, the interns.
What's up, guys?
Shout out to all the people who came out to watch a couple interns talk about technologies we didn't know existed a few weeks back. I'm Basir, that's Bill, if those pictures aren't too obvious.
And just FYI, our internship technically ended last Friday, so we're not being paid to be here. So after the talk, if you guys want to hit us up, get our GoFundMe, that'd be great. So let's get started. The first thing we noticed when we were working with Flutter is just how easy it is to set up your environment. And that's for two main reasons, right? The Flutter SDK is extremely lightweight, and it has a built-in CLI, which has all of the features that you need, right? Being extremely lightweight means that you can get started on any machine you want. You can even run it on a computer with as little as 2 gigabytes of RAM comfortably, in contrast to something like Gradle and Android Studio, which take at least 4 gigabytes to be comfortable with, which greatly lowers the barrier to entry for devs. Additionally, the Flutter CLI is great, which means that you can use any text editor or IDE that you want, in contrast to doing native development, where you're pretty much stuck with Android Studio and Xcode.
So Bill and I don't have a lot of mobile experience before coming into this internship. I programmed for Android a little bit, made a couple apps, but the one thing that was apparent to me straight off the bat was the layout and the logic. So to my understanding, Android, you have the templating done within a separate XML file and all your logic done in a separate file. But with Flutter, all the layout and the logic are written within the same files using the language Dart. And so that makes everything super easy to see how different elements within the screen interact with each other, because the behavior and their appearance can all be found in the same place.
Additionally, Flutter makes it extremely easy to access system-native APIs and to interact with the operating system, right? So for example, Flutter can just as easily do networking, access battery percentage, and change the color of the status and navigation bar as a native app can. So right here you can see some example code written in Dart to access the battery percentage on your device. So it's super easy to get started, and it feels just like a native app.
Everything in Flutter is a widget. Seriously, everything you see on the screen is a widget. And so this simplifies the process in choosing what element you want to put in your application, because if you want to have some sort of application, you go to the same place, the widget catalog, and it's all going to be there. Additionally, there's parent-child relationships among widgets. So for example, a list view is a widget, and it has children, which is a list of widgets. So this creates some sort of shallow, wide class structure, and this allows for you to basically replace different elements on the screen without having to worry about what class it belongs to or anything like that. They're all just widgets. Additionally, it's not limited to any sort of native widget sets. For example, you can do material design, you can do Cupertino, or you can make your own custom styles of widgets. So that's really cool. And there's two different kinds of widgets. There's stateless widgets and there's stateful widgets. If you don't want your element on the screen to be changing as the app is running, then you're going to want to use a stateless widget. However, if things do change, then as the app runs, then you're going to want to have a stateful widget, which is essentially going to have properties which, if they change, you can call a set state function, which will rebuild the entire application or that widget itself, and then it'll show the changed properties for that widget.
Getting started actually writing your code, Dart and Flutter are extremely simple to work with, right? So there's basically 3 steps to do if you want to import an external library, right? You're going to first create a pubspec.yaml file, and then in that, you list the name of the package and the version number under the dependencies field. And then from the CLI, you run flutter packages get, which actually fetches the package from the Flutter repository. And then finally, within your Dart file, you do an import of the actual package name. So, for example, we used Firebase. So these are the exact code snippets that we used within our pubspec.yaml and our Dart code, respectively.
So there's 3 things within Firebase that we found extremely helpful. One was remote configs, one was the database, as you saw in the code snippet before, and one was push notifications. So for remote configs, this came in clutch when we were trying to have URLs or strings within our app that weren't necessarily hard-coded in, because those URLs can change over time. And so we use Firebase remote config, where it has key value pairs stored on the back end, so that you access the URL based off of the key, and the value can be updated in real time, or reflected real time in the app when you update it within the back end. So the way you do that is that you set an expiration time for the fetching of those URLs. So essentially, every time that you fetch a new key value pair, that will expire based off of what you set it to. And then when it's not expiring, when it hasn't expired yet, it's just going to use a cached version of it. And if it's expired, it'll just refetch it again. And so you can see those updated results within your app. So this is how you're going to actually use remote configs. At the beginning, you can see, as we saw on the previous slide, you're going to first import it, and then you're going to want to get an instance of the remote configs. And then from there, you can set defaults, but we didn't really do that with our application. We kind of just set the fetch with the duration that I talked about previously, and then you're going to activate it. And from there, you can just get string, which is just plug in the key, and then it's going to give you that value that you want from the remote configs on the back end.
So using remote config is great when you're dealing with simple data, but we needed a database. So we chose Firebase's real-time database. Essentially, the real-time database is just a giant JSON object. And the great thing about it is that it's actually real time. So any changes we make on our back end are shown instantaneously on the front end. You can also easily set it to automatically persist on the disk just in case you lose network connection. So to demonstrate that this is real time, we're going to have you guys, just kidding. Here's some example code of setting up the real-time database. You can see right here that you just initialize a Firebase app in your Dart code, and then you configure it with properties that are different for iOS and Android. The only difference is that on iOS you have a Google Cloud Messenger Sender ID, and then on Android you get an API key, and you can get all this from the Firebase console. It's super straightforward. And then within your Dart code, you initialize the database, pass in that app that you just initialized, and then get a reference to the URI path from the database that you want to use. So for example, if you want to fetch the messages property from your database, you just do a child reference and pass in the path to messages. And then with that reference, you'll do an asynchronous call to get a snapshot of the data within the database. It should be noted that because this is asynchronous, you're going to want to do it within either an asynchronous context or within, if you're building a widget, a future builder or a stream builder so that it can be passed back into a synchronous context easily. So now we'll go ahead and do a demo. So if you guys can go ahead and take out your apps, you'll see if you go to the schedule view page, we'll go ahead and edit the title of our event from Flutter, Firebase, and Interns to Interns Are Awesome. And it reflected live within the app, just like we were planned. We'll go ahead and change it back.
Not that it's not true.
It is true.
So Firebase also has cloud messaging, and there's 2 things that come with that. There's either push notifications or data messages. So the thing that we used was the push notifications. And from this chart, you can see the different behaviors that would happen when you receive a push notification from Firebase, whether the app is in the foreground, whether it's in the background, or whether it's been terminated. So for example, if you get a notification on Android where the app is in the background, the notification is going to be added to the system tray, and that's where you're actually going to get the notification, and then it's going to call the onResume function. That's going to be configured when you set it in the front end. I'll talk about that in the next slide. And so continuing on with that, if you get a notification on Android when the app is terminated, then it's going to first add it to the system tray as it did before, and then it's going to call the onLaunch function. For if the app is in the foreground, it's only going to call the onMessage function, but we want it to have you be able to get push notifications when the app is in the foreground. And so what we did was, within the onMessage function itself, we just pushed out a local notification that looked exactly like the one that Firebase sends you. So right here is where you would see that in action. So you would first get an instance of Firebase messaging, and then from there, you do Firebase messaging.configure, and that's when you set those onMessage, onLaunch, and onResume functions. And so now we're going to have a little demo. If you look at your phones, you should be getting a notification just about now.
So over the course of the summer, we definitely learned that Flutter is extremely powerful when used within its scope. That's a key qualifier, right? So the Flutter IO website has a huge, beautiful widget catalog with all pre-made material and Cupertino designed widgets, which are very easily filterable. Lots of great documentation on there for how to get started, from setting up your environment to deploying to iOS and Android to deploying to the app stores. Additionally, they have a great package repository over at DartPub. We use that extensively throughout our project.
But if you use Flutter outside of its scope, things can get difficult fairly quickly. Not everything that we wanted to implement within our app was found readily in the widgets catalog or the packages, and so we had to get some workaround solutions for those. So one recommendation that we have is that if you want to make an app with Flutter, just go through all the features that you have or want to implement within that app before starting the project, and cross-reference the widgets catalog as well as the packages repository that Flutter has available to make sure that you'll be able to do that without going through workaround solutions. We actually had to do that with the Twitter feed. So now we're going to take a look at Twitter, a case study, and all the pain that it caused us. So my boss's boss really wanted to get this Twitter feed into the app, and so, oh, he's just coming. So first thing we did was we looked for a Twitter package, because there's TwitterKit, or there was TwitterKit available for Android and iOS while we were developing this, and so we figured, hey, what if there's a Twitter package for Flutter? We don't know. So we went and we tried to look for one. Thing was, there wasn't any. There wasn't a Twitter package that handled API requests. There was, but it wasn't working with Dart 2, which was useless for us, and there definitely wasn't one that actually built out a UI for us. And so we had to look for another solution. So one cool thing about Flutter is that it can bring up native Android or iOS code. And so we thought, perfect, we'll just use TwitterKit for Android and iOS, just pull that up, and we'll have our thing. Problem with that is that when Flutter pulls up native Android or iOS code, it puts it onto a different page, meaning you won't be able to see the app bar, you won't be able to see the drawer. It would just be a terrible experience because it wouldn't feel good. And so we couldn't do that. So then we thought, what if we used a web view? I know Joni already knew how to make a web view for Twitter that just goes through the feed of a certain specific handle, and a quick Google search showed that we can make a bot that just retweets everything with #AndroidSummit. So combining those two, we could easily make a Twitter feed. I was excited, Joni was excited, we're like, all right, perfect, let's just go try to make this web view. And then 5 minutes of silence later, we couldn't find anything. We looked through the widgets, and there was no web view widgets. And we looked through the packages, and although there were packages which allowed for web views, they would be plopped onto another screen, and it wouldn't be embedded, causing the same problem I described earlier. So we had to continue looking for other solutions. But as Jared became a little more adamant about having this Twitter feed, we slowly came to the realization that we were going to have to build everything from scratch, essentially making our own TwitterKit for Flutter. And that turned out to be a project in of itself, as you might imagine. We had, a week, maybe a week and a half to complete this part, and it had to get done, and so we had limited time to actually get this done. Also, we're interns, so we don't have that much experience. And so one problem that we actually came across, we were building it, everything was fine, but one problem that we came across was emojis and the way Dart sees them. So when you get an API response from Twitter, it's going to give you the full text, if you set the parameter, which we would want to, and then it's going to give you a display text range. Now, obviously, Twitter sees an emoji as one index, which it should. But the problem is that Dart sees a bytecode as an index. And since some emojis can be 2 bytecodes, if you had an emoji at the end of your tweet, and you try to take a substring of that, then it's going to show that half of an emoji, that little question mark, because it sees half an emoji. And when you put that into a text widget, everything crashes. So we couldn't do that. We had to find a workaround solution. And although this is kind of hacky, we kind of just looked for the next URL right after the ending index and kind of cut off before that because we knew that it had to end, the full text had to have URLs outside this display text, linking quotes and retweets and stuff like that. So that should work as long as somebody doesn't put like 15 or 20 emojis and ends with the link.
Please don't do that.
Don't do that. And it won't crash, it just won't show the link. It's not that, like, yeah. So another issue that we ran into was API search limits. So obviously Twitter has API search limits for how many times you can hit their API. So if we were using the same keys and everyone was accessing the Twitter feed, then it would hit that limit fairly fast, and it would just not review any more results because Twitter would be like, you hit your limit. And people wouldn't see any tweets and they'd be like, your app doesn't work. So I was really worried about this one problem because I was like, I put all this effort into making a Twitter feed, and I'm not even gonna be able to come see it through realization because we're gonna be hitting search limits. But then I come in Monday morning, super tired, and then I look at my Slack and I see Joni, a message from Joni late at night saying, hey, I made a backend service to solve the issue. And I was just like, okay, two things came through my mind. One thing, cool, we're actually gonna be able to have the Twitter feed in here, it's gonna work. Second, does Joni actually expect me to be working on the weekends? Because I can't do that. So what he basically did was he made a backend service which cached results. And so within every 5-second interval, you're not gonna be able to hit the Twitter's API. It's gonna give you a cached result if you try to do it more than that.
So the solution was to build a REST service that pulls the data from Twitter and then writes it to Firebase, and then...
Not to Firebase, to the app itself. We weren't going through Firebase for Twitter. But yeah,
so
essentially
it's essentially a Twitter writer that writes your GUI?
No, the backend service, we can answer the question outside the talk, but yeah. So that got the whole job done. But as you might imagine, it's not going to look exactly like Twitter. I mean, if you look at it, all the retweet icons are material icons. Those are not actually Twitter retweet icons. But it got the job done. So the reason why I'm going through this little case study is to just showcase that if you want to use Flutter, make sure that you look through the widgets catalog and the packages catalog, or the packages repository, to ensure that your app can do everything that it needs to do, and you won't have to go through all the heartache and workaround solutions.
So, as we found throughout the summer and as we presented to you today, there's a lot of pros and cons with working with Flutter. Firstly and primarily, a huge pro with it is that it's extremely easy to learn, right? And that's thanks to the fact that it's written in Dart, which is C-like. So if you've ever worked in any C-based languages, it's extremely easy to get started. And secondly, it's also easy to learn because there's great Flutter.io website made by Google, maintained. All the documentation is there, everything you need to know, and a great widget catalog that you can get started with using. Also, they have the Dart Pub, which is a great place for third-party resources. It's extremely quick to develop in, very quick to do rapid prototyping with because you don't have to maintain 2 separate code bases for native Android and iOS. And also, a huge feature that makes it fast to develop in is called hot reload, which is basically if you have a debug device plugged in, you can change your Dart code and then click save and hot reload, and it will change on the device live without having to change views or anything like that. So it's very good for debugging and testing and configuring. Finally, it's much more responsive than other cross-platform frameworks just because of the technical nature of it, because it compiles then into machine code and it's rendered in a graphics engine rather than doing something like React Native, for example, which is run through an interpreter. But that being said, there are a few cons with using it that we've found. First and foremost, it is still release candidate, so it's still beta software, still a little bit buggy. A lot of times we would get not so useful results from the terminal if we had errors or if the app crashed. It would just say, oh, go post the issue on GitHub. So that wasn't great. It's not as fluid as native apps when you're doing it in debug mode. We definitely noticed that a lot when we were, for example, scrolling through the list view. It was definitely buggy when we were doing debugging. It shouldn't be like that on prod, it's not. But that's just because of the fact that when you're doing debug mode, it's running through a virtual machine rather than through Flutter's graphics engine. Also, it's dependent on whatever widgets and packages that are available to you at the time. So a huge thing with it is that the community is still relatively small because it's new software. So you're going to want to make sure, as we discussed with our Twitter case study, that existing third-party packages exist for the use cases that you want to cover. And if not, just take that into account with your development time allocation. Finally, the app size may be larger due to the framework overhead, right? The fact that it installs its own graphics engine and doesn't render anything natively. So the actual app size is 4 megabytes last year versus 20 megabytes this year. So these are just things to take into consideration.
All right. So if I could go back 10 weeks and change any decision about the use of Firebase or Flutter or intern choices, would I do that? And the answer is no. It turned out to be a really great experience. Flutter and Firebase work really seamlessly together, so Google did a really great job, since they own both, of making them work seamlessly, and it was a really easy integration. Are we Flutter experts? No. Stick around for the next talk for a real Flutter expert, but we really enjoyed it. Next steps, so a lot of people are asking, are we going to open source it? The plan is yes, to open source it. So we're not going to do that today because I want to take some time to go through the code, clean it up. Not that it's not great, you did a great job. We're going to polish it a little bit, make sure we go through legal the right way, and make sure Capital One gives us the sign off on it, since they paid for it basically. And once that happens, you'll hear about it probably through the Android Summit social media channels or whatnot. So keep looking out for that. But our intention is definitely to open source it. Thank you. Now it's your turn. So if you have the app, you'll notice now at the bottom, if you go to our event in the app, there's a new widget showing at the bottom. It says, what did you think? And this will happen throughout the day today whenever you go to any of the events. 30 minutes after the event start time, that will appear on the event details screen. And that's a way for us to get feedback from you guys. So tell us what you think about the presentation, ours, and any future ones. And what this does is it helps us become better as presenters. It helps Android Summit become better in determining the types of things that you guys like to hear about or not hear about. And everyone wins, right? And if you come to Android Summit next year, it'll be that much better. A few shout outs before I leave. Good timing. Michael Jones standing right in the back there. Thanks, Mike. Some great inputs from the whole Android Summit organization team in terms of things they wanted to see in the app, things they needed from us that needed to be in there, great ideas. So the good idea fairy got a little crazy there towards the end, but we were able to get a lot of it in, so I'm glad we were able to do that. Jared had to step out, but same for him. Is Kim Spencer in here? Holy cow, she's here. So my joke was gonna be, I have never met Kim Spencer in person. And so this is the picture I have, and this is the only way I've ever seen her. So we're gonna have to meet afterwards. This is awesome. So Kim did all the designs. So she's the designer for the app, so anything that you love about the design is all her. Thanks, Kim. Sandeep Gadi is not here, but he was the other team lead that was helping to organize and write code and all the things that go along with it, so shout out to him. And then Jared Alexander, another one of the team leads on the Android side, who just had a lot of input and feedback on the app as a whole, the use of Flutter, ideas, all those great things. Is Naveed in here? Hey, he is here. Look, he does not have a picture on social media anywhere. So also not on our slide. But Naveed actually was responsible for last year's app. So he was a valuable resource for us this year. We hit some of the same roadblocks with the iOS thing, so sorry. And then finally, the Capital One TDP internship program, who were able to provide us with these two guys. So with that being said, we're right at time. I have one quick announcement. Jared's not back in here yet, but we're a little behind schedule because of some technical difficulties. So the afternoon schedule has been shifted by 20 minutes, and tell me if I'm wrong, Mike. So by 20 minutes to the right. So when the first presentations post-lunch were supposed to start at 1, they now start at 1:20. Everything after that will shift by 20 minutes. Luckily, the people that wrote the app are standing right here, so we're going to do those updates real time, and you'll get those in your app without having to change anything. All right, so with that being said, thanks for coming. We hope you enjoy the rest of your day. If you have any questions, catch us afterwards. Otherwise, take care. Thanks.